Hello coders, I welcome you all. As you know, we have been working on our project, Water Portability Prediction using machine learning. In the last video, we used a standard data science project template called cookie cutter, right? Now in this video, we are going to perform data and code versioning, which is very important in the project and is a widely used concept in the industry as well. Don't you worry, we will start from scratch again. We will download the cookie cutter template once again and start from scratch. You might know using GitHub, we can perform code versioning, right? However, because of many issues, we can't use Git for data versioning. For data versioning, we can use DVC, data version control. So in this video, we are going to perform code and data versioning in the DVC pipeline that we have created for our project. This is a very important concept. Just follow the video and you will understand everything by the end. Now let's first open command prompt and let's install cookie cutter first by using following command. Pip install cookie cutter. Let's press enter. You can see in my case requirements are already satisfied because I have already installed cookie cutter on my system. Now let's clear this and let's download the cookie cutter template using following command. Cookie cutter -c v1 https github.com/driven data /cutter data science. Let's press enter. You can see it is asking to re-download the template. Let's press yes. Now here we have to give project name. Let's give water portability. Let's press enter. Same repo name as well. Water portability. Let's press enter. Author name. Data thinkers. Let's press enter. Here we can give project description. Water portability prediction using ML. You can give any. Let's press enter. Currently we are not selecting any license. Let's press enter. Also we are not going to use S3 bucket. So let's press enter. Also we are going to skip AWS profile as well. Let's press enter. Here we have to select Python interpreter. We are going to use Python 3. So let's select one. Let's press enter. Now all done. Let's move to our project folder. This one. Water portability. Let's press enter. And from here, let's open VS Code using this particular command code dot. Let's press enter. You can see we have successfully downloaded the standard template for data science project cookie cutter that you can see over here. You can see various folders and files designed to manage our machine learning project that you can see over here. So now let's first remove the files that we don't require for this project, which are provided by default in this cookie cutter template. Let's move to src data. Let's remove this. Also this Python files as well. In features, let's remove this. Also this file. So here in models, let's remove this. Also these Python files as well. So as you know, we have already created these Python files for data collection, data pre-processing, model building, and model evaluation, which we will put here. That's why here we are removing default files from here. Also, don't forget to rename this folder from models to model. I think all done. So as you know, in our project, the data, code or model can change, right? To maintain versioning, we are going to use Git for code and DVC for data. Means we are going to use GitHub to maintain code versions and DVC to maintain data versions. So let's click on this terminal and let's create new terminal. And let's first initialize Git using this particular command, git init. You can see we have successfully initialized Git for this particular project. Also, let's initialize DVC using this particular command, DVC init. You can see we have successfully initialized Git and DVC for code and data versioning. Now let's move on. Let's move to the GitHub website and create a new repository for this project. So here, let's click on this new and let's give name to this repo, water portability. Let's keep other things as it is and let's click on this create repository. Now done. Let's copy this path, this one, and let's back to VS Code. So you can see that we have initialized Git locally using this particular command, git init. Now let's connect this newly created remote repository to our local repository. So let's clear this. To do that, we have to write following command, git remote add origin, and let's paste this particular link. So here we are assigning the name origin, this one, to our GitHub remote repository. Let's press enter. Now done. So as you can see here, we have created a Git repository for maintaining code versions. Similarly, we need to handle data versions as well, right? So let's open code that we wrote earlier. So as you can see in our code, in data_prep.py, that we have filled the missing values with the mean value of the respective column that you can see over here, right? The corresponding data has been generated with these mean values here that you can see over here. So as you know, in machine learning, we need to perform experiments to achieve good results. Machine learning is all about experiment, right? So we want to perform a simple experiment here. Instead of filling missing values with the mean, like this, we want to fill them with the median of the respective column. So if we do this, the code will change and corresponding data will also change, right? Code and data go hand by hand in machine learning, right? So here, both the code and data need to be managed in the combination. You understand, right? As you know, in machine learning project, there are many ways to perform these experiments. I am using this example just to explain the concept of code and data versioning. So as we discussed, we are going to use Git to maintain different versions of the code. So we can retrieve a particular version if needed. And we are going to use DVC, data version control, to maintain different versions of the data. So we can retrieve a particular version of the data when needed. So the question is, why DVC? Because DVC is very effective at handling data versioning. DVC is not a complete version control system on its own. It relies on Git for versioning. DVC utilizes the concept of external storage to manage large data sets. It stores metadata, means data about the data, in the Git repository, while the actual data is stored in a separate location, such as Google Cloud, network storage, or local disk. This approach keeps the Git repository lightweight. Don't you worry if you can't understand everything at this stage. By the end, you will understand it all. In this video, we are going to use a local disk for data storage, and we are going to store our data in a temp folder. So now let's back to our project. So as you can see here, we have created Git repo to maintain code versions. As I said, in this video, we are going to use a local disk for data storage inside temp folder. So let's create this. So for that, we have to use this particular command, dvc remote add -d. My remote, you can give any other name as well, and let's open temp folder like this. So I have pressed Window R and we have to write this particular command. %, temp and %. Let's press OK and let's copy this path and let's paste it over here. In temp, let's create new folder with name DVC1. You can give any. Please remember here -d specifies the default storage. This means you can create multiple storage locations as well. Let's press enter. Now you can see we have successfully created this particular remote directory to maintain our code. So you can see that here we have set up a Git remote repository to maintain different versions of the code and a DVC remote to maintain different versions of the data that you can see over here. So this setup allows us to retrieve particular versions of code and data when needed that you can see over here. Let's check Git status. You can see these many files are untracked in Git because we have just added the cookie cutter template and we haven't committed anything yet. Let's check DVC status. You can see there are no data or pipelines tracked in this project yet. So let's clear this and let's add all the files in the staging area using git add dot. Dot means all. And let's perform our first commit, initial commit. Let's press enter. Now done. Now let's add the various files, Python files and YAML files that we have created earlier to this cookie cutter template. So for that, in this data folder, let's create new file with name data collection.py. Also in this data folder, we have to create another file as well with name data_prep.py. We do not have any file for feature engineering. Let's move to this folder model and let's create new file model_building.py. Another file model_eval for model evaluation.py. Also let's click here and let's add params.yaml file. Also let's click over here and dvc.yaml file. Let's click over here. Let's move to our previous template. Let's select code using Ctrl A. Let's copy the code, Ctrl C. Let's move to our newly created template and let's paste the code. Let's save this code. Now again back to our previous template, Ctrl A, Ctrl C. In new template, Ctrl V. Let's save our file. Now third file for model building. Our previous code means our previous template, Ctrl A, Ctrl C, and here Ctrl V. Let's save our file. Now code for model evaluation. This one, Ctrl A, Ctrl C, here Ctrl V and Ctrl S for save. Now params.yaml. Let's move to our previously created template, Ctrl A, Ctrl C, the newly created template, Ctrl V, Ctrl S. Now next file, dvc.yaml. Again Ctrl A, Ctrl C. Let's move to our newly created template, Ctrl V, Ctrl S. Now all done. Let's clear this and let's try to execute our pipeline. using this particular command, DVC repro command. As you can see, our pipeline is working properly in our newly created template as well, that you can see over here. As you know, we are going to maintain code versions and data versions. As you know, code versions are maintained by Git. So the question is, which files does DVC track to maintain data versioning? So as you can see in this particular file, dvc.yaml, DVC automatically tracks the files listed under the outs section. This one, here, this, and this. So DVC automatically tracks the files listed under the outs section of dvc.yaml file. And you can see these files are listed in the cache folder as well with unique hash values to maintain data versioning, that you can see over here. And also you can see very important file for data versioning, dvc.log file, you can see over here, which is a metadata file. As we talked about data file created for our original data to maintain data versioning, that you can see over here, which maintains data versions using these unique hash values, that you can see over here. So please remember, this metadata file, dvc.log file, is stored inside GitHub, while the actual data is stored on our local disk that we have created repo currently in our local system temp folder, right? So using the dvc.log file, DVC manages the data versioning. And please remember, currently we are using everything inside DVC pipeline. So DVC handles data versioning automatically when we use a DVC pipeline like this, that you can see over here. So you can see the advantages of using a DVC pipeline. So DVC handles data versioning automatically when we use a DVC pipeline. Now let's clear this and let's check DVC status. You can see data and pipelines are up to date. As I said, DVC handles data versioning automatically when we use a DVC pipeline. Also, let's check Git status. As you can see, these files are untracked because we have just added them, right? We need to commit these files now. As we discussed earlier, we are going to perform a simple experiment, right? Instead of filling missing values with the mean like this, we will use the median of the respective column. So if we do this, the code will change here, right? And the corresponding data will also change here. So we will maintain code and data versioning accordingly. The first version will include the code and data with the mean values that you can see over here. And shortly we will create second version. And the second version will include the code and data with the median values, right? So now let's clear this and let's add our first version of the code. So git add dot means all. Let's commit the changes. Add pipeline using mean, that you can see over here. Our first version of code and data, that you can see over here with mean. Let's press enter. Now done. Let's clear this. We have just performed code versioning. Also we have to perform data versioning. So for that we have to use DVC push. So this DVC push command will push the current version of the data to the repository that we have set up in the temp folder for this project, right? For version 1 with min. Hope all of you are clear with this. Version 1. Now let's perform git push origin master. So this will push all our code to the remote repository that just we have created on GitHub with the current version of the code, which means the code with the mean values. You understand that, right? Version 1 of the code. Let's press enter. So you can see currently we are maintaining version 1 for code and data with mean, that you can see over here. So we have just performed DVC push and git push origin master. This is to maintain version 1 for data, and this is to maintain version 1 of the code. Hope all of you are clear with this. Now let's move to GitHub and let's reload this page. You can see over here. You can see data folder is not there. Even in the reports, there is no file like .json. And here you can check models as well. There is no file model.pkl because they are now tracked by DVC, not by Git. Please remember this. So now you can see we have successfully saved our version 1, code and data both. So from here, we are going to start our simple experiment to explain the concepts of data and code versioning. Now let's make some changes to our pipeline and commit these changes. We can modify the pipeline in several ways, right? If we change the code, the pipeline will change. If we change the data, the pipeline will also change. And even if we modify params.yaml, the pipeline output will change, right? Also, if we add some extra stages to our file, this particular file, dvc.yaml file, or change the params.yaml file, then our pipeline will change. Means our output of pipeline will change, right? So let's first make changes to the params.yaml file and let's set an underscore estimators to 1000 instead of 100. Let's save this file. Let's clear this and let's execute our pipeline using this particular command, dvc repro command. You can see model building is taking some time because currently we are using an estimators 1000, right? Now all done. Let's clear this and let's check DVC status. You can see data and pipelines are up to date because it is automatically handled by DVC when we are using DVC pipeline. Now let's check Git status. You can see because we have changed an underscore estimators, the params.yaml file has been updated, that you can see over here. And the dvc.log file, which is our metadata file, will also change due to the update in the hash value as DVC handles data versioning as well. So for that, let's clear this, git add dot, and let's commit this changes. Add pipeline mean with 1000 and underscore estimators. Let's press enter. Now done. Let's perform DVC push. Also git push origin master to update our GitHub repo. Now all done. Let's clear this. You can see we have currently changed the params.yaml file. As we discussed earlier, we are going to perform a simple experiment. Instead of filling missing values with the main, we will use the median of the respective column. So we are going to change this particular code. So if we do this, the code will change and the corresponding data will also change, right? So we will maintain code and data versioning accordingly. The first version will include the code and data with min that we have already performed. And the second version will include the code and data with median. As you know, we are already maintaining the first version of the code and the corresponding data with min. Now let's create the second version of the code and the corresponding data with median value. You can see we are currently saving our processed data with the names train underscore processed and test underscore processed. Here missing values are filled with min. Please remember this, version 1 of our data. Now let's change our code first. So here in place of min, let's use median. Here median values and here with median and here also median underscore value. Let's save our code and here don't forget to call this with median. Now we have to call this function with the name median. because just we have changed it to median, this function. And also here, let's save data with median. We can visualize the changes. Let's save our file. Also, we need to perform changes in the model building and the model evaluation stages as well. So here, yes, in place of median, let's save this file. Let's move to model evaluation file, and here test underscore processed underscore median. Let's save this file. All done. Let's try to execute our pipeline using DVC repro command. All done. You can see we can execute our pipeline with new version of the code that you can see over here. Let's clear this. Let's check DVC status. You can see data and pipelines are up to date because here DVC works automatically. Let's check Git status. You can see these files are untracked. You can see dvc.log, and just we have updated these files. So let's clear this. Let's add these files and let's perform commit. Add pipeline with median, which is our second version. Let's press enter. All done. Now you can see that we have our second version of the code and the corresponding data. Let's perform DVC push and also git push origin master to update our remote repo. Now done. As you know, we have two versions of the code and the corresponding data. Now we can switch between version 1 and version 2 because we are maintaining code versions in GitHub and data versions using DVC. So we can switch between versions. Let me show you this. To switch between versions, we need to check our commits. So let's clear this and we can check our commits using this particular command, git log -1 line. You can see our commits. Add pipeline with median, add pipeline mean with 1000 n estimators, add pipeline using mean, initial commit. As you know, we are currently at version 2 with the median that you can see over here. And let's check data as well. You can see currently we are at version 2 with median. Suppose we want to switch to our first version with mean, right? So we have to go to our previous commit using the following command, git checkout, and this particular has value. Look at here. Let's press enter. You can see over here. We are at version 1 of the code that you can see over here with mean. But what about the corresponding data of version 1? Here you can see. So you can see that the data is using median values that you can see over here, which means we are currently have the code from version 1. You can see, and the data from version 2 that you can see over here. That is true because we are maintaining code versioning with Git and data versioning with DVC, right? So here we have fetched the code with Git that you can see over here using git checkout. But for the corresponding data, we need to use DVC. Let's clear this and let's perform DVC checkout. Look at here. You can see over here. You can see that the data has now been changed. So now you can see everything is set. We have version 1 of the data and the corresponding code as well that you can see over here. So this way we can switch between versions of code and data as per our requirements that you can see over here. Let me show you one more time. So you can see that we are currently at version 1 of the code and corresponding data that you can see over here, mean, and data with mean. Now suppose we want to switch back to version 2, which includes the code with median and the corresponding data as well. So again, first we have to perform git checkout. Let's check commits on GitHub. 4 commits and add pipeline with median. Let's copy this. Let's move to VS Code. Let's paste it over here. Let's press enter. Please look at here. You can see over here. Also, you can check model building as well, median. Model evaluation, median, that you can see over here. But here you can see previous data with mean is still present. So here we have to perform DVC checkout. Please look at here. Let's press enter. You can see over here. So this way we can switch between versions, code and data. You can see we have successfully achieved data and code versions using Git and DVC. Git is used for code versioning while DVC handles data versioning in our pipeline that you can see over here. So now the question is, what if someone wants to clone our project and they have to perform some step? Let me show you this. So let's open command prompt. Let's move to D drive. Here is our project. Let's copy this URL and let's move to command prompt, and we have to write git clone and let's paste our URL. Let's press enter. Now done. Let's enter water potability, this one. Let's press enter, and from here let's open VS Code. You can see over here. So this way someone can clone our project. You can see our files, but you can see that the data folder is not here. Let's open terminal and new terminal. To fetch the data, we have to use DVC fetch command. So now data is available inside our cache. Next, we have to perform DVC checkout. Please look at here. Now we have data with our current code, median, that you can see over here. Suppose you want to go back to code with mean. Means we want to go back to our version 1 of the code and data. So for that, we have to use this particular command to check our commits. So here you can see code of version 2 and data of version 2. Now first let's use git checkout and pipeline using mean. Let's copy and paste it over here. Please look at here. Let's press enter. You can see code with mean, but still we have data with median. Let's clear this. Now first we have to perform DVC fetch and then we have to perform DVC checkout. Let's press enter. Please look at here. Data has been changed, that you can see over here. So we are at version 1 with mean, with code and data, that you can see over here. So this way we can switch between versions of code and data. Hope all of you are clear with this. So this way we can manage code and data versioning for a machine learning project, that you can see over here. So we have successfully achieved data and code versioning. Hope all of you are clear with this. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye bye. See you in the next video.